everyone. Thanks for coming out to my talk. I really appreciate it. This is actually my first time. No, I've been to Atlanta many years ago. First time at Devnexus. So thanks for the speakers for inviting me. Really appreciate it. And today we're going to be talking about Spring Authorization Server. So really excited about this. Really excited about this project. We've done a lot in the last couple of years. So really happy for you guys to come here and check out and see where we're at and where we're going. And thank you for coming. My name is Grandja. I'm on the Spring Security team. Give a little bit of context. Been leading the OAuth efforts the past 7 years, I think it is, or is it 6 years? I can't even remember, right? It's been a while. But we introduced OAuth 2 client support back in Spring Security 5. We're at 5.7 right now, or 5.7's coming out. And then resource server support we introduced in 5.1. And then Spring Authorization Server we started literally 2 years ago. The first commits went in April 2020. So 2 years in the making. We've come a long way. We're really happy where things are at. There's still a ton of work to do, but we're excited. We're excited for what's going to happen this year and next year. And I'm really excited you guys are here. And let's get going. Today, the main objective of today's talk is I'm going to basically demonstrate, this is about getting started, right? Getting started with Spring Authorization Server. I'm going to demonstrate how to configure Spring Authorization Server, or what the default configuration is if you're just going to start an instance up without configuring it whatsoever. Then I'm going to show you how to custom configure it, the different customization endpoints or configuration points. And then I'm going to show you, because Spring Authorization Server, as all Spring frameworks, is very extensible, right? There's a lot of ways you could extend the default features. So I'm gonna show a couple of mitigations against access token leakage that I've implemented, extending the features on top of what's already provided with Spring Authorization Server. So that's basically the goal of today's talk today. This is the overview. We're gonna start off with really quickly current set of features that are implemented as of today. Then I'm going to go over the core model and components, because you really got to get a grasp of the core model, the main components, the central components, and understand the interaction between them two and where they're used and how they collaborate with each other. So we're going to go over high level design of that, and then we're going to build from there. We're going to go over the default configuration. When you stand up a Spring Authorization Server without configuring it, what exactly is enabled by default? Then we're going to go over how can I customize it depending on the use case that you have, right? And then I'm going to do a demo, right? The first few slides, the first half of the talk is going to be slides, but the custom features via extension will be demos. I'm going to show you a couple of demos on a couple of mitigations against access token leakage. It's called sender constrained access tokens and audience restriction. All right, so we'll get to that, and then we'll wrap it up with the feature roadmap where Spring Authorization Server is going with the next set of features. Okay, so let's really quickly. I'm just going to go over this really quickly. You could get into the details here, but as far as the feature list, there's a wiki page on the Spring Authorization Server site, the GitHub site. Just go to the wiki here, and then here's the feature list, right? So we're keeping this up to date. This is eventually going to go in the reference documentation, which is coming up in May 23rd. So we're going to get to that later on, but we'll be adding that there. But right now, so Spring Authorization Server conforms to OAuth 2.1, right? So it's still in draft form. Biggest changes from OAuth 2 to OAuth 2.1 is resource owner password credentials grant and implicit flow is deprecated, right? So we're not implementing that in Spring Authorization Server. And I know a lot of people have been asking about the resource owner password grant because they probably have it implemented in their existing applications. So they want that backward compatibility. The good news is once again, you could add your own implementation of resource owner password grant. But we are not going to be providing that, but I'm going to show you how to add it. And it's fairly simple to add it if you do need it, but I would highly advise you not to use it and just move away from it and use authorization code with Pixie. But sometimes you don't have a choice, right? You got to have a migration path. Anyway, so we support authorization code, client credentials, refresh token. JWT access token format was initially introduced with 0.2.3, the recent release. We introduced opaque access token support. So that's a big addition there. Client authentication methods, obviously basic and post. And then we added private key JWT, client secret JWT. There's a default user consent screen that you could also customize, provide your own. Pixie, of course, that's part of OAuth 2.1. It's required for authorization code grant. You got to be able to revoke a token. You got to be able to introspect the token. These are provided. And then we have provider configuration endpoints, OAuth 2 Authorization Server metadata. So where do I find my authorization endpoint? Where do I find my token endpoint? This is where clients can self-configure themselves. The Jose specifications, JWT, JWK, signed JWT, which is JWS, and OpenID Connect Core, pretty light right now on features. I mean, authorization code grant support, as well as the user info endpoint, but there's a lot more to OpenID Connect, and that's going to be the main theme going forward after release 0.3. We're really going to start building out the OpenID Connect support. We're pretty solid on the OAuth 2 side, but OpenID Connect is definitely going to be a major feature development going forward after 0.3 is out. So there you have it. That's pretty high level there. What we have. Okay, let's jump into the second section. So here we have the core models. Everything starts with a registered client, right? Registered client is a representation of a client registered with a provider, right? Registered client, right? There's different attributes of a registered client. You have the authorization grants it could perform, the client authentication methods it could authenticate with, it's allowed to authenticate with, the scopes it's allowed to request, the registered redirect URIs for redirect-based flows like authorization code grant and so forth, right? Registered client repository is the central component. It provides these registered clients. However it provides it, whether it's dynamically registered using OpenID Connect client registration endpoint, or it could just be provided from an out-of-band means. Typically organizations will have their own UI, their own CRUD kind of application where you administer clients, add them, edit, and so forth. But ultimately, the registered client repository provides registered clients. Wherever it comes from doesn't matter, right? Registered client repository obviously is the one required component. Everything else defaults. Provider settings is the exception to, like, the two main components that are required are registered client repository and provider settings. I'll get to that in a bit. Then we have OAuth 2 authorization, right? So when a client goes through an authorization grant flow, let's say the authorization code grant, when it completes that flow, right, the end result is at least an access token, right? I mean, the whole purpose of a client is to get an access token and access a protected resource on behalf of a user, if it's the authorization code grant flow, or on behalf of itself, if it's client credentials and system-to-system interaction, right? But the bottom line is, at the end of an OAuth 2 authorization flow, whatever that grant type may be, there's at least an access token, so the client could use it, call the protected resource. That is what an OAuth 2 authorization is, right? It represents the end result of a flow, and there's different attributes. Obviously, there's an association between the client and the resource owner, right? The resource owner, if it's a authorization code grant flow, but if it's client credentials, then it's the client ID. That's the principal, right? So it's the client, registered client, and the principal as in the resource owner or the client, right? So you at least got those two, right? And then you have an access token. Depending on the flow, though, there might be more tokens. So, for example, the OpenID Connect flow, you're going to have an access token, optional refresh token, an ID token, and an OAuth 2 authorization code. Those are all OAuth 2 tokens, right? So, OAuth 2 authorization has a list of OAuth 2 tokens. Those are the attributes of an OAuth 2 authorization. Obviously, this is created at the end of the flow. But at the same time, they're also, for example, the token introspection endpoint, token revocation endpoint, they look up tokens, right? A token comes in, I want to introspect this token. It looks up, uses the OAuth 2 authorization service. Let's look up find the OAuth 2 authorization that's associated with this token and do its thing, right? So this is where the OAuth 2 authorization service is used. So register client repository, OAuth 2 authorization service used everywhere, right? All the protocol endpoints. OAuth 2 authorization consent. So this is your typical consent page, right? Do you authorize this client to access, profile, email, or it could be, more fine-grained like claims, like, I said email there, right? Or it could be permissions, read, write. Whatever your authorization model is, it's very dependent on your system. But we want to save these authorization consents because when a client goes through a specific flow, the first time it needs to get authorized by the resource owner, right? And then if the resource owner says, yeah, okay, you could access my resources on behalf of myself, right? Then we want to save that, right? Because we don't want to keep asking, right, the resource owner each time. So the authorization consent is saved there. And this is also another place where, you have providers, Okta, and they provide a means to revoke these authorizations, right? So when you're building a provider, you need this capability too. You don't just administer clients, but you also administer consents and revoke them, right? So there you have it. So those are the really the central components, right? Now, here, OAuth 2 token generator. So this was actually just introduced in the latest release, 0.2.3. This was needed. We originally only supported JWTs and everything was pretty hidden, right? It wasn't exposed. You couldn't really reuse it. So we created this, we introduced this OAuth 2 token generator, right? It generates OAuth 2 tokens, right? It's very powerful because right now, with this capability, you could easily provide your own OAuth 2 token generator implementation with your own proprietary format. Doesn't have to be JWT, doesn't have to be opaque, it could be anything, right? So it's very powerful. And we're going to document the use of this in the reference documentation because, maybe some organizations want their own format. It's definitely a use case. So anyways, the relationship here is, OAuth 2 token generator generates an OAuth 2 token. It uses an OAuth 2 token context, right? So the OAuth 2 token context has attributes in there that the OAuth 2 token generator introspects, right? While it's before it generates. Like, what kind of token do I need to generate? Is it an access token? Is it a refresh token? Which client is associated with this flow that's in flight right now, right? Who's the principal? Is it a resource owner, client ID? All these attributes you want to be able to, access so you could actually associate it with the token, right? So that's the OAuth 2 token context. And it also optionally uses an OAuth 2 token customizer, primary use case. Everybody wants to customize a JWT. They want to add their own, typically authority information, like whether it's roles or permissions, but it might be, some extra information about the user, whatever it may be. This is the OAuth 2 token customizer. You register an OAuth 2 token customizer for a specific format, whether it's JWT or opaque, and then you have access to the claims or the headers. Well, headers in the case of JWT, you have access to it, and then you can either add, update, delete, whatever, right? So that's the OAuth 2 token customizer. Then we have provider context. This also was, I think this was introduced in 0.2.2, I can't remember now, or maybe 0.2.3, but the provider context, so it's contextual information of the provider at runtime, right? Like, what are the different attributes of the provider? I mean, the most common is provider settings, right? This provides the authorization, the endpoint URI, so authorization endpoint URI, token endpoint URI, revocation endpoint, and so forth. This is where you could customize that endpoint. So instead of OAuth 2 token, you could do maybe something like V1 OAuth 2 token, right? So the provider settings, as I mentioned earlier, as far as the default configuration goes, is the only two required components are obviously your registered client repository. You need clients or nothing's going to happen, and your provider settings being. right? You just simply could register the bean with the default settings, or you could customize the endpoint URIs. The provider context, there's also provider context holder. Just like in Spring Security, the security context holder, it's a thread local pattern. You could access your provider context through this holder and ultimately your provider settings, because sometimes you need access to this, especially when you're customizing a token. You might want access to the provider settings for whatever reason. There's always special logic, right? So this is these. Excuse me. These are really the central components. There's a lot more authentication providers and filters, but ultimately the filters and authentication providers use these components that I just explained. Okay. So let's just jump in to the next section here. Default configuration. So if you want to stand up a Spring Authorization Server, with the absolute default configuration, how do you do that? Okay, you got two ways of doing that. It's just, I want to actually kind of backtrack. I want to answer a question before I even get into this, because you see enable web security there. People have been asking, what's the relationship of Spring Security with Spring Authorization Server, right? So I want to answer that right now. Spring Authorization Server is Spring Security, right? It uses Spring Security, it uses Spring Web, Spring Core. Ultimately, it's just an extension on top of Spring Security. It provides, OAuth to OpenID Connect implementations of filters and authentication providers, right? So it is Spring Security. Spring Authorization Server is Spring Security. So you need to obviously enable web security, just to answer that question. So the first method is the easiest, right? There's the OAuth to Authorization Server configuration class. You just import it and you're done, right? The only thing is, once again, just to reiterate, is you do have to register client repository bean and provider settings bean. Those are the only two required components. By default, you'll get a in-memory OAuth to Authorization service and an in-memory OAuth to Authorization Consent service, right? Obviously, this is good for the getting started experience. You're not going to use this in production. But that's the easiest way. The second way is we're not using that configuration. We're not importing it, right? We're ultimately just registering the authorization server security filter chain, right? And we're just calling the static method apply default security on HTTP and then HTTP.build, right? Return the security filter chain. That gets composed in the filter chain proxy or the Spring Security filter chain, right? So that's the other method, right? That's the method you're going to be using, right? You're gonna want to apply the default security. Then you're going to want to customize, right? But I just wanted to kind of show you the two methods. The first method is the easiest getting started experience. So what exactly is enabled when the default configuration is applied and there's no custom configuration? These are the client authentication methods that are enabled, right? Basic, post, private key GWT, client secret GWT, and Pixie, right? So Pixie, proof key for code exchange, originally designed for public clients, as in SPAs or single page applications, right? These applications, they're running in a browser. This is it's not a secure environment. It cannot maintain its secrets, right? It's a public client, right? So you never want to have a client secret, in your browser application, because you could easily decompile or just view page source and you just expose a secret, right? So you want to use Pixie, right? Which is, I'm not going to get too much into that protocol, but it's a protocol where on the authorization request, code challenge, a code challenge method parameters passed, and then on token endpoint there's a code verifier, right? So protection, it protects against the authorization code ejection attack, but it's a form of CSRF protection as well. But the one thing I wanted to point out here is, you see, and confidential, right? So this was originally for public clients, but OAuth 2.1 strongly recommends, and that is actually required in certain flows, to use Pixie for confidential clients. The only specific flow that it's not required is when you're using OpenID Connect and the client is using the nonce parameter. Then it's not required. All other cases it's required. But the thing is that's pretty strict to allow that by default. First of all, OAuth 2.1 is in draft form. Not all servers are supporting that. So if you actually enforce that, then clients just wouldn't work, right? Unless you made the necessary changes. But within Spring Authorization Server, so it's not enabled by default, but you could enable it via a quick configuration. I'm going to show that to you later on. The default endpoints that are enabled in the default configuration, obviously authorization, endpoint token endpoint, introspection, revocation, JWK set endpoints. So these are the public keys that are exposed by the provider that the client and resource server use to ultimately verify the signature of a JWT, right? And then the authorization server metadata endpoint. So this is the OAuth 2. And then you got the OpenID Connect provider configuration. This is the OpenID Connect that builds on OAuth 2 server metadata. This is ultimately the provider configuration. What does this provider, how is this provider configured, right? Where is the authorization endpoint? Where's the token endpoint? What client authentication methods are supported, and so forth. And then we have the user info endpoint. So these are the default endpoints that are enabled by default. Okay, so let's jump into, so that's the default configuration. Let's jump into customizing the configuration, because you're going to be customizing, right? Everything I talked about so far, this is your getting started experience, right? But ultimately, how do we customize? So let's go over the current set of configuration points. We're going to be expanding a lot more. This is where we are at today. Right, so OAuth 2 Authorization Server Configurer. So this is ultimately a Spring security configurer, super interface, like top level. You could view this as same thing as hpsecurity.form login, hpsecurity.OAuth2 client, and so forth. So that's what this configurer is, and we have these different configuration points. Customized client authentication, right? And we're going to demonstrate that as part of the demo. Customize the authorization endpoint. So, for example, I want to use a custom consent page. I don't want the default consent page. Token endpoint. This is where you would customize an extension grant type. If you really need the password grant type, this is where you would do it. Token introspection, revocation. Sometimes there's custom parameters, right, that are needed depending on the implementation. This is where you could support custom parameters. And then we've grouped all the OpenID Connect specific protocol endpoints under OIDC. And here we have the user info endpoint. Typically, you're going to want to map a custom user info response. You might want to include some extra user information and so forth. This is where you would do that. And then the client registration endpoint. So you notice they're disabled by default, right? Not everybody wants an endpoint where you could dynamically register a client, because there's inherent security risks with that, right? So by default, it's disabled. If you want to enable it, you just literally configure it and it's automatically enabled. Okay, so this one here, so generic endpoint configuration, you see there, endpoint, that doesn't exist, right? So this is just a general configuration DSL, right? We have, and before I even get to this, for those of you that are not too familiar with Spring Security, let me just kind of go through a flow, the core classes and how a request is processed, right? So a request comes in, right? Comes into the Spring Security filter chain, right? Then there's authentication converters. That's the first step in the processing pipeline, right? The authentication converter, consider that pre-processing stage, right? Authentication converter takes an HTTP servlet request and it converts it to an authentication instance. So let's use a concrete example. We'll talk about client authentication, right? Client's authenticating, right? Request is coming in. There's an authorization header and it's basic, right? So there's an authentication converter instance that for client authentication, it sees the authorization header, it accepts that request, processes it, parses the client ID, client secret, creates an authentication instance. In this case, an OAuth 2 client authentication token, because that is the authentication class when a client authenticates, right? So that's what happens there, pre-processing stage. An authentication instance is created by an authentication converter, in this case, OAuth to client authentication token. Comes back, the filter passes it to an authentication provider, right? The processing stage, right? And this is, once again, this is a general pattern in Spring Security. This is not OAuth 2 specific. So now the authentication manager gets called with the authentication instance. It has a list of authentication providers that also process specific authentication classes. So the HTTP basic client authentication provider will process that authentication instance, and it'll do its thing. It'll authenticate the client. If the client successfully authenticates, then it gets delegated to an authentication success handler, right? Or the success response handler, right? The generic name. If it fails, it gets delegated to the authentication failure handler, right? So that's the general pattern, right? Authentication converter delegates to an authentication provider, indirectly via the manager. When it's successful, then it goes to the success response handler or the authentication success handler or the failure handler. That's how all of Spring Security works, right? So let's look at some concrete examples. So let's look at the authorization endpoint. So we've stuck with the naming as per spec, right? So if you look at the authorization code grant flow and you look specification there, or the OAuth 2 specification authorization grant flow, you'll see that it's named authorization request, authorization response, or access token request, access token response. So you'll see the pre-processing stage, the authentication converter, right? We have authorization request converter, right? Authentication provider, we're keeping that consistent. It's just consistent throughout all configuration points. Same thing with the error response handler. This is where the OAuth 2 error is returned. The only specific naming conventions is the pre-processing stage, the authentication converter. So you see authentication request converter, and then authentication response handler. So this is obviously the authorization response, right? So that's the concrete example. You'll see the pattern here, right? Now we have the token endpoints, right? We have access token request converter, access token response handler, right? You see, that's the general pattern. So once again, especially with the token endpoint, common use cases I want to support. I'm going to show this during the demo. I want to support a custom parameter, right, on the token call, the access token call. So what I would do is I would plug in a custom access token request converter, right? That's what I would do, and I'm going to show that. Now, if I want to extend and again, provide the password grant implementation, but don't. But anyways, you would provide authentication provider implementation. You plug in authentication provider here, right? Once again, I might want to, on the access token response, I might want to return extra parameters, right? That would be the access token response handler, right? So that's how you go about extending Spring Authorization Server at the different protocol endpoints across the board. The request processing stage, authentication converter, and then the success handler, the response, error handling, response handler. Client authentication, as you can see here, general pattern across the board, okay? All right, let's check my time. Okay, I'm doing good with time here. Let's go into the demo and check out some code. So basically we've talked about core model and design and components, right? Did an overview of that. Default configuration, customizing the configuration. Now we're going to extend, right? Because Spring Authorization Server, there's a lot more work to do, and people are definitely waiting for certain features. And we're going to get to it, but if you can't wait, then this is an example of how you could go about adding it before we actually add the support. And I wanted to use something useful, right? Something that's going to secure your application architecture even further, right? So there's a couple of mitigations So the OAuth 2 Security BCP, Best Current Practice, I always get confused why they name it that way, but it's a BCP, Best Current Practice. So the OAuth 2 Security Best Current Practice provides 2 mitigations for access token leakage, right? So access tokens, they can get leaked very easily. There's many different ways. I won't get into all the different ways, but there's a lot of different ways. And given typically they're bearer tokens that are used by clients, so the bearer of the token, the holder of the token can use it, right, to access protected resources, right? So this is a major security issue when access tokens get leaked. If it gets leaked, how can we mitigate it from actually being used at a resource server? These are the 2 examples: sender-constrained access tokens. So just as the word implies, it's constrained to a specific sender, the access token that is, right? So only that sender, or the sender being the client that initially received the token, only that client can use it if you apply these mitigations, right? Or this implementation of this mitigation. There's a specification out there, 8705 OAuth 2 Mutual TLS Client Authentication and Certificate-Bound Access Tokens. The idea here is the client mutually authenticates with the authorization server. Mutually authenticates as in, there's an exchange of X509 certificates between the client and certificate or server, right? Client sends its client certificate, server sends its server certificate, and there's a mutual TLS handshake that happens first, right? Then at the end of, or when the authorization server is about to mint the access token for the client, it will obtain the client certificate from the request, it'll compute the thumbprint, and then it'll put that thumbprint as a custom claim in the access token, right? So it's bound, right, to that specific client's identity, right? Because the client's identity is that certificate, right? So that's the first step. And then the resource server on the other side has to apply the same check, right? So the client now has the token, the access token. There's the thumbprints associated in the token, calls the resource server, and the resource server does the same thing. So mutual TLS connection happens, resource server obtains the client certificate, does the exact same calculation, right? Computes the thumbprint, and then compares it with the claim in the JWT. If it matches, then the client has proven to the resource server that the client owns the private key that's associated with that public key, right? Proof of possession, they call it, right? So that's the idea, right? It's very, like the code that I have, the sample I have, it's involved, right? I'm not going to get into everything, especially setting up client certificates. It's very involved, and I'm using a specific tool that I'll get to, to do all that setup for me in an easy way. So that's the one way, and this ultimately prevents token replay, right? So this is a huge specification. We will be providing this implementation after 0.3 is out. This is a very important specification. The second one is access token privilege restriction. You've probably seen this one, many times, where the audience claim, right? The audience claim, like, who is this intended for, right? This access token, who is it intended for? It's intended for this resource server. That's what it's about, right? This ultimately, this doesn't eliminate token replay. It reduces it. For example, let's say we have an access token, right? Let's say your authorization checks are very, coarse-grained, as in your access token has roles, right? And your resource server authorizes on those roles, right? You're only allowed to access this protected resource if you're in the user role. That's pretty high level, right? Compared to more fine-grained, you're only allowed to access this resource server if you have message.read, right? So if we go on that, role-based authorization check user, that access token could potentially be used at multiple authorization servers, multiple resource servers, right? because it's very high-grained user, right? As long as I'm a user, I could access many different resource servers within my application topology, right? But if it's fine-grained, like message.read, right? And typically you're probably only gonna have one, resource server, that supplies messages or provides messages, right? So you can only use that there, right? But let's just assume your application topology is this higher grain authorization model, user, based on role-based authorization checks. Now, if you implement this, right, then it's the same idea, right? It's the same idea. The client sends a resource request parameter to the authorization server saying, okay, I only want to access this specific resource server. Provides an identifier of the resource server. Typically, it's a URL. Could be something else. It depends on the implementation. I've done a URL in this case for the resource identifier. And then it adds that as a custom claim in the JWT. So the same thing happens. The resource server applies the same check like it does on the thumbprint on the client certificate. It looks for the resource claim, the audience claim, because it's going to be in the audience claim, and then it'll basically, compare that URL to its URL, right? If it matches, then the request continues. If not, it gets rejected, right? So it restricts the use of that token only to that resource server, right? So that's the idea there. So let's get into the first demo. Before I get into that, as I mentioned, there's a lot of code here. Like I had to set up, the certificates, right? Like this is the messaging client sample, or the messaging sample that's in the Spring Authorization Server repo. I'm just using that. So, I have client authorization server, Spring Authorization Server, resource server. I have to set up mutual TLS, communication between the three, right? Setting up certificates like a trust store, key store generate. It's not easy, right? This tool here, if you haven't heard, anybody hear about Spire or Spiffy? Nobody? Check it out. Really, really cool tool. I'm really excited about this tool. Like ultimately, so Spiffy is a set of specifications that provide identities to workloads, okay? From very high level workloads, as in, and this is very generic, like workloads could be anything. It could be a web application, it could be a database, it could be a cluster, right, and so forth. In this case, it's my web application, right? That's why I got the stereotype there. And Spire, so Spire is an implementation of the Spiffy specifications, right? So I have the Spire server running, right? And I have the README in this branch, and it's right at the end of this slide here. There's detailed steps, downloading Spire, configuring it, starting it up. You just follow that, you'll get this up and running, right? And then you could play around with the code, because there's a lot of code, I can't show it all. But you could play around with it, get familiar with Spiffy and Spire. But ultimately, it really helped me set this up, at least the mutual TLS side of things. It's always complicated doing that. So that's what we have. So that's the interaction between the three, right? It's all mutual TLS. I'm going to show you one of the certificates. This is a quick, hierarchy of it. I just wanted to point out, if you look at client there and you see SVID, right? So Spiffy Verifiable Identity Document, right? So what this is, it's basically a Spiffy document that allows, basically you have the private key and the client certificate. Client certificate obviously has a public key associated with it. So this is what's obviously used during a mutual TLS handshake, right? So Spiffy or Spire provides this SVID, to each of the workloads, right? And at bootstrap time, I got it all configured. It basically sets up my SSL context, right? Using this Spire integration. And we'll look at one of the certificates, but that's the hierarchy, right? So the Spire comes bundled with this root CA. You'll see everything in the middle there where you have the Spiffy scheme. So that's a Spiffy ID, right? Spiffy identifier uniquely identifies the workload. and associated with the SVID. So that's the hierarchy. The intermediate CA, that's ultimately the Spire implementation that just gets generated, I believe, at runtime. And then obviously each of my applications get an SVID. Okay. So let's jump into the code and just do a time check here. I'm doing okay. Let's look at what does it take to implement that first demo. So let's look at this. The first thing I want to point out is the registered client. Okay, see the registered client here? I got client authentication method TLS client auth, right? So this is what I'm implementing. This is not in Spring Authorization Server yet, but it's coming. And then I have the one thing I wanted to point out here: client settings. So client settings is, there's we'll look at it right now, and I'll just show you what you could configure here, because this is actually what I was mentioning earlier. If I'm just kind of backtracking here, but I wanted to point this out. If you want to require Pixie for a confidential client, this is where you would configure it, client settings, right? As you can see, require proof key. There's a builder there that you could set the require proof key. But the one thing I wanted to point out here is .settings. So you could add custom settings. So I'm leveraging this to specify the SPIFFE identifier for this registered client, because that SPIFFE identifier is ultimately the SAN name, the SAN attribute of the X509 certificate. SAN as in subject alternative name, right? Name. Like an X509 certificate has many different attributes, right? Subject is the most common one, but the way Spire works is it associates the SPIFFE identifier in the SAN attribute, right? So I need to set this somewhere in my registered client and use that during the authentication process. So I'm showing that here right now, and we'll see it in the authentication provider. As you can see, that's the SPIFFE identifier for this registered client. So I set that up first, right? And then let's look at the implementations before I show you how I plug it in. So we have, the pre-processing stage, right? Here we have, I'm going to make this a little bit bigger. All right, X509 client certificate authentication converter, right? First thing's going to happen here, I'm going to extract the client certificate, right? If it's there, then I know I'm going to continue processing. If not, return null. That's the protocol essentially, because then there might be another authentication converter that'll process the request. So in this case, there's a client certificate, and then we're going to extract the client ID. But ultimately, whatever the attributes are required for the OAuth client authentication, we just extract it and we create the OAuth client authentication token, right? So this is the authentication instance for OAuth client authentication, right? And then we'll return this, right? So it's pretty easy, right? And then we have the provider, right? So this gets returned. Then we'll go to the provider. This is a little bit more involved, right? So this will ultimately get called. All right, we're expecting a client authentication token. We just want to make sure that the incoming request, is actually TLS, same kind of idea, right? Is this authentication provider meant to process this, right? If it's TLS client authent, then yeah, continue. All right, and then there's a few things here. We're looking up the client ID, make sure it's exists in the registered client repository. Make sure that this registered client repository is registered to use this authentication method. We're expecting an X509 certificate. If it's not there, fail, right? And this is where that check happens, right? So this has subject alternative name. As you can see here, registered client, get client settings, SPIFFE ID setting name. That's what I showed you earlier, right? So this is, and I'm not going to get into that bit of code, but ultimately what happens here is get me that setting, which is SPIFFE scheme, and then ends with messaging client. is that the same SPIFFE identifier in the SAN attribute of the X519 certificate? If it is, authenticate. If not, fail, right? So that's essentially the two implementations to allow for mutual TLS client authentication. The converter, provider, that's it, right? So how do I plug that in now and ultimately extend Spring Authorization Server? Let's look at that. And here it is here, right? Exactly what I showed you earlier, right? We use the client authentication configuration point, we supply the authentication converter, we supply the authentication provider. Now we've extended the client authentication method features, right? With TLS, mutual TLS client authentication. And that's it, right? So that's literally it for allowing mutual TLS client authentication. But the next step is we got to bind that thumbprint to the access token, right? And as I was talking about earlier, you know, when that access token is being generated by the OAuth2 token generator, we need to customize it, right? So OAuth2 token customizer, right? So here we register a bean, OAuth2 token customizer, it'll get picked up and self-configured. Because the default is JWT, you'll see the generic type JWT encoding context. Depends on you know, what's enabled for that specific client. If you've configured that client for opaque access tokens, then this would be a different generic type. But by default, it's JWT. So I'm providing the JWT encoding context generic type. This is what I'm expecting, and this is how I would go about customizing it, right? So I'm evaluating the OAuth2 token context. Am I, as in the OAuth2 token customizer, being called at the access token generator? Or this could be, you know, generating a refresh token or ID token. So I want to evaluate that first, right? So is this access token type? Is the token type access token? If it is, okay, that's what I want to customize. Then it goes into this, you know, bit of logic here. I extract the OAuth2 client authentication instance, the client authentication instance. I compute the thumbprint, and then I add this custom claim, right? So that's literally how I'd go about adding the thumbprint to the access token. The next step and the last step is now I got to do the same authorization check or validation check on the resource server side. How does that code look like? And then we'll run through it and take a look at it. So here's the resource server side, and I'll put a breakpoint here so we can look at the JWT when it comes in. But it's the same kind of idea, right? I'm extracting the client certificate, same computation, and then I'm comparing that computed thumbprint with the value in the custom claim in the JWT, right? Pretty easy implementation there. So that's literally it. Like that, what I just showed you is the implementation of OAuth2 mutual TLS client authentication and certificate-bound access tokens. So let's actually run through this. I'm going to put a breakpoint here so we can actually see the token. I'm going to do a time check here. Okay, I'm going to have to kind of boogie if I'm going to show you the other one. Okay, just so you know, when you start up this sample, again, follow the README step by step, you're going to get the same message. The reason you're getting this message is because when I look at this certificate, right, and I wanted to just kind of show you, this is that hierarchy that I was telling you about, right? We got SPIFFE here, and then down here in the SANS name, I don't know if you're going to be able to see this, but you see SPIFFE local, right? And then the intermediate CA, we got example org, and then this is the authorization server certificate, right? And there's a SPIFFE identifier for the authorization server, right? So I just don't have this certificate in my trust store within my browser keychain. That's why I get this. Not a big deal. Just proceed. That's what I'm going to do. Proceed to localhost. Then I get this, right? So the authorization server, it wants the client to mutually authenticate. It doesn't require it. The OAuth2 client does mutually authenticate, but I'm the resource owner. I'm running my browser. I have not set up my certificate in Spring Authorization Server's trust store. So I'm just going to cancel, which basically means I'm not mutually authenticated. I'm just authenticating the server, or the browser's authenticating the server. So I'll just do that just to proceed. So when you're going through it, you got to do the same steps unless you actually set that up, which is involved. But you want to just basically do what I just did. Okay, so I'm going to go through the authorization code grant flow here. Okay, yeah. I'm going to just actually run this through here. Come back. No, that's not what I was expecting, of course. Let's see here. Let's look at this JWT. I think I know what happened here, actually. Let me just look at the JWT here first. Okay, you can see the certificate there, right? X5T, there's a thumbprint. You know what, I know what happened. So with Spiffy or with Spire, what happens is it's got built-in key or certificate rotation. So I had this running for at least an hour. So that's probably what happened, and that's why it's failing. So what I'm going to do is I'm going to actually restart the servers here, and then we should be good. So yeah, just give me a second. I literally got 5 minutes though, so I'm gonna have to kind of rip through this. I might not be able to show the audience restriction, but that one's a lot more simpler than this one. And once again, the sample's there. You could check it out. You could always reach out to me as well if you have any questions. But let's at least go through this demo, and then I'll answer some questions. Something happened here. Okay, that's good. Okay, let's start it up here. I'm going to just start a new window. Okay. Cancel that. Okay, then we'll authenticate. Okay, we'll go through the authorization code grant flow. Okay, so we're good now. That's definitely what happened. And I already kind of showed you the certificate there, and it's going to pass, right? And I got my messages, right? So just to make sure, right? Just to make sure that this check is happening, I'm going to just simulate a failure, right? It's going to be too complicated for me to use another client certificate because I have to mutually authenticate, right? To use another client with another certificate, but using client's A token to do the token replay attack, right? It's going to be complicated for me to set that up. The easiest way for me to set up that, to prove out that validation is in the access token, OAuth token customizer. I'm just going to, put something different, or I'm going to put an invalid thumbprint, right? So this is the thumbprint here. I'm just going to append one character. That's it, okay? Just to make it fail, right? So ultimately, and we'll look at the JWT token there, and we'll see it fail. I'll start this up again. We'll inspect it on the resource server side. We'll see that X at the end. We'll see it fail, and that just shows you that it's been, applied. The mitigation has been applied. Okay. Start this up. I always like to start a new window because even though it's incognito, it's just what I do to be on the safe side. Cancel that. Go through this flow here, and then we're going to inspect the JWT. Although it's probably duplicated. Yeah, let's take a look here. Okay, there's the claim. I mean, there's an X there, but there could have been an X, but we'll just let it go through, and we're expecting it to fail. And there you have it, right? Unauthorized, right? So yeah, so I got 2 minutes left. I'm gonna have to basically wrap up there, but that's the audience restriction. Really, I'll show you the code. I won't go through the demo because it'll take a little bit longer. But just to show you the code, it's pretty pretty easy. Actually, you know what? I'm not gonna do that because I got 1 minute left. I'm gonna take questions, okay? And I'm gonna put this slide up so everyone could basically just get there's the demo branch there. Take a picture of that. Again, there's a README, step by step. You'll be able to get it going. The audience restriction check, the implementation, a lot more simpler than this one. But yeah, check that out, and that's it. Thank you very much. But let's definitely. Does anyone have any questions before we wrap up? Yes.
Can you quickly talk about the roadmap?
Sorry?
Can you quickly talk about the roadmap?
About what? Oh, the roadmap. Yes, of course. Yes, that was my end slide there. Reference documentation is badly needed. That's coming. We're a little bit behind already because there's always something to do, but that's going to get delivered in 0.3, May 22nd, I believe it is. And we're going to keep building on it, especially the how-to guides. But as far as the conceptual, the concepts, kind of what I talked about today, the protocol endpoints, how do you configure, all that kind of, content, that's going to be there. The how-to guides, there'll be 2 or 3, but that's going to be an ongoing basis, right? We'll keep adding how-to guides, but that's definitely coming for 0.3, and we'll just keep adding. That's the main priority for 0.3, getting rid of some deprecations. After 0.3 is out, this implementation here, OAuth 2 Mutual TLS Client Authentication Certificate Bound Access Tokens, that's going to get implemented. But OpenID Connect support is going to be a big one, right? So we're really going to focus on that. OpenID Connect Core, OpenID Connect Session Management, logout, all that kind of stuff, right? There's a lot of work to do there. So that's the roadmap.
Is there a plan for a multi-factor authentication?
There's a how-to guide set up for that, because multi-factor, that's authentication for the user, right? Again, this is an authorization server, right? It has nothing to do with authentication, right? It integrates with an authentication system, whether that's LDAP or an external identity provider like OpenID Connect or whatever, right? So that's that system's responsibility. But we know this is being asked a lot, so we're going to provide either a sample or a how-to guide, so it shows you how to do it. But it's not a feature that would be implemented in Spring Authorization Server. Any other questions? Yes?
Right now you focus on one client, right? So one client can access the authorization. What if we have more than one client? How will it set that up? Will these certifications be from the some keyboard and then do this?
Well, every client has to get its own certificate, because that ultimately it's identity, right? So it's definitely doable, right, with Spire. I just didn't do that. I just kind of created something as simple as possible, even though it's not simple, right? This sample, but ultimately, those certificates, however you set up your PKI, infrastructure, which is very complicated to set up, ultimately each client has to have its own client certificate, right? So this sample is missing that, right? It's expecting, but once again, this is a very simple application. I just wanted to demonstrate, but each client has to have its own certificate. So there's more involved. That might be, I might add that, another client in this sample just to demonstrate how that would work, right? As a kind of second step. Yeah. Yeah. Right on. Any other questions? Yeah.
Well, looking at I didn't see where you were actually verifying the signature of the
JWT?
Yeah.
Oh, that's
Was that missing something? I mean, maybe
no, not at all. The JWT decoder, which is part of Spring Resource Server or Spring Security, I didn't show that bit of code because this is all about Spring Authorization Server. But the JWT decoder, which lives in the Jose module, it does that, right? But it ultimately has to get the keys, right, from the JWK set. Yeah.
Okay.
But if you look at the sample, if you look at the resource server config class in the resource server, you'll see the JWT decoder configured, and this is the component that validates the signature.
All right, and you're pulling. Oh, you have a place where you say where you go get those.
The keys?
Yeah.
Yeah, the Spring Authorization Server exposes the JWK set endpoint, and then the resource server fetches it from that endpoint, gets the keys, and then it uses the public key to verify the signature.
Gotcha.
Yeah. Right on. Hi.
The previous question and this question, I was expecting like it is mapped with the client, right? Like earlier, whatever we are using, anybody can able to get the token and they could able to authorize. But here in this authorization server, we are expecting like it is bind to the client, whichever the client. And in this code, what is it? I'm understanding is like each client will have its own certificate.
Yeah.
There could be multiple certificates within the server itself.
Well, yeah, there's a fly here. Each client would have to have its own certificate, yes. However that's set up, that's really, a configuration on the OAuth 2 client side, right? The only thing the authorization server you set up is what I showed you there, the Spiffy identifier. If you're using Spiffy, that is, depends what you're using, right? But that's the only thing that I set up on the Spring Authorization Server side. That whole PKI infrastructure with all the certificates, that's all has to be set up on the OAuth 2 client application. And there's many ways to set it up, right? I'm using Spire because it's just easy. Yeah, or easier. It's not easy. Okay, yeah, no worries. Have a good one. Brian, what's going on, buddy?
What's going on, man?